Hi, this is Thomas. Welcome to Trigonometry. Today we're looking at trigonometric identities, and in particular we're going to look at the Pythagorean identities. There are a variety of trigonometric identities. We've already seen some. For example, a reciprocal identity is cosecant of angle equals 1 over sine of angle. A quotient identity is tangent of angle equals sine of angle over cosine of angle. These are examples of identities. And now we want to focus on the Pythagorean identities. And the basic form of the Pythagorean identity is sine of angle squared plus cosine of angle squared equals 1. Additionally, if we divide everything by cosine of angle squared, we're going to end up with tangent of angle squared plus 1 equals secant of angle squared. And if we were to take the original equation and divide by sine of angle squared, we calculate to 1 plus cotangent of angle squared equals cosecant of angle squared. These are all forms of the Pythagorean identity. We can use these and other trigonometric identities for proving trigonometric identities and for solving trigonometric equations. So let's look at some examples. First, we want to prove that cotangent of angle over cosecant of angle equals cosine of angle. And I'm going to work with the more complicated side of the equation. In this case, that's the left side, and my goal is to simplify to cosine of angle. I can split this up as cotangent of angle times 1 over cosecant of angle. And cotangent of angle is cosine of angle over sine of angle. And cosecant of angle is 1 over sine of angle, which is the same as sine of angle over 1. And now I can cross multiply to end up with cosine of angle over 1 equals cosine of angle, which is equal to cosine of angle. So that's a proof of the identity cotangent of angle over cosecant of angle equals cosine of angle. Let's look at another. Prove cotangent of angle times cosine of angle plus sine of angle equals cosecant of angle. I'm going to work with the left side. Cotangent of angle is cosine of angle over sine of angle times cosine of angle plus sine of angle. Now, cosine of angle times cosine of angle is cosine of angle squared over sine of angle plus sine of angle. And now I will multiply sine of angle by sine of angle over sine of angle. And the reason for that is so that I can create fractions on the left side of the equation that have like denominators. Then I can combine the numerators. So we have cosine of angle squared over sine of angle plus sine of angle squared over sine of angle, which I can combine as cosine of angle squared plus sine of angle squared over sine of angle. And now I'll use my Pythagorean identity. Cosine of angle squared plus sine of angle squared is 1. Thus, this is the same as 1 over sine of angle, which is the same as cosecant of angle. And looking at the original equation, the right-hand side of the equation is cosecant of angle. So we've proven the original identity given as cotangent of angle times cosine of angle plus sine of angle equals cosecant of angle. So in this lesson we've learned about trigonometric identities, including the reciprocal identities of cosecant, secant, and cotangent, the quotient identities of tangent and cotangent, and the three forms of the Pythagorean identity that we listed on the left side of the whiteboard. And then we worked through 2 examples of proving trigonometric identities and working through applying the identities that we know to result in an equality of both sides of the equation at the end. More trigonometry content is on the way, and I will see you in the next lesson.